Can you see the slide?
Yes, sir.
Okay.
Yes, sir. Yes.
So, all of you are having code, calculator, and a note sheet, because we will solve some of the problems here itself. Okay. So you can see the pile foundation. I think we had only one class for you or two class. How much you have covered in the
One
class?
class.
We have calculated. We have gone for the load carrying capacity of pile. Am I correct?
Yes, sir. Yes, sir.
So first of all, if you go for the pile foundation and the load that will be subjected to. So pile foundations, can you tell me the projects where the pile foundation is generally used? Can you remember? Anyone, please? Shayan Ghosh. When we are going for pile foundation? Kobita? Kobita,
Sir.
when we are going for pile foundation? When we are going for it?
So we use pile foundation when the bearing capacity of soil is much less than the loads. The required area is very high. Then we go for pile foundation.
Okay, so when that top soil profile is not capable of taking the load from the superstructure, we are transmitting the load to deeper dependable soil profile, isn't it? To pile.
Yes.
Now, what are the projects generally will go for pile?
Sir, bridges, flyover,
The power
buildings.
plant.
Yes.
Power
Bridges,
plant.
flyover, power plants, then thermal, your
Transmission power.
towers.
Sir,
Yes.
underground
And can you use
network.
Water
Yes.
intake.
Water intake, very good. Now, another one thing, if we come to the loads that will be coming to the pile, that will be vertical load and say horizontal loads. Vertical will be tension as well as compression and lateral loads. Now, if I ask you the question that, can you tell me some of the projects where lateral load and uplift will be predominant? Huh?
Sir, electron. Sir, light.
You can see the intake structure. Intake structure means there will be hydrodynamic loads, isn't it? So lateral loads are likely to be more. So in that case, you are likely to get say more lateral load. In bridges also, lateral loads will be coming. Then in high-rise building, due to wind and earthquake, lateral load will come, and tension is generally will be coming. In transmission towers, you know that high-rise structures mostly governed by the wind, and huge lateral load comes, and some piles will be subjected to compression and some will be tension, isn't it? So that's why we have discussed the load carrying capacity of pile. Compression and tension, I think, is completed. Huh? These are the structures you can see, or what we have discussed already in the earlier classes. Now, material wise, we have discussed. Construction methodology wise, classifications we have discussed. Now, factors govern the selection of pile, soil profile, geotechnical expression code, type of structures, availability of materials, load analysis, and environmental condition. Now, in the previous classes, we have already completed. You can see a few picture, that is Kollani Expressway. This one, you can see this is a flyover. This type of structure you can see. This is the flyover, and this top one, it is completely pre-stressed deck. Have you read pre-stressed concrete?
Yes, sir.
Have you read or not?
No. No, sir.
Why? Anyway, next semester
Not
somewhere it is
in
there.
the syllabus.
you can see this. This is PR. This is PR cap, isn't it? You say this is the PR cap. You can see how thin it is because pre-stressing has been done. Here the whole deck has been pre-stressing has been done. And this one, I think I have shown you this structure earlier. This is 276 meter transmission tower, isn't it? And here you can see the racker piles are there. It will be subjected to huge lateral load due to hydrodynamics effect as well as wind effect. And these pile caps, what is the thickness? I have told you 3 meter. And this is the intake structure you can see. So now we have gone for the load carrying capacity of single pile. We have already completed. And in single pile, this friction part and band bearing we have explained, and how the load carrying going on and how we get the load settlement curve. Types of pile failure. Then we have explained the IS code method for calculation of the load carrying capacity of pile. This part I think we have covered in the earlier classes, isn't it?
Yes, sir.
For single pile, load carrying capacity under tension and compression we have completed. Uplift capacity also we have completed. Okay.
Sir, but sir, the type of pile failure is not mentioned.
Huh? Which part?
Type of pile failure not completed.
This thing you can see in any book, it is there. Depending on soil, you can see if it is very low strength and here it is very steep soil, then there is possibility of buckling. Okay. And in case it is homogeneous soil, then this type of soil profile you will get load settlement curve. And in case this is very stiff and this one is soft, then you will get this type of load deformation. So this is there in any book you can see. And whatever the basic principle we have explained over here regarding the load transfer, this is there. Now we have explained, I think, board cast in situ concrete piles as per IS 2911 part 1 section 2. Can you remember this one? Uplift capacity also we have completed. Do you know what is belt anchor? Sometimes piles you will see that they are made like this. Mostly in expansive soil, you are going for either, this is called bale. Okay. Suppose this diameter is say D, say here it will be enlarged diameter will be there. And as you know that in case of expansive soil, the piles may be subjected to uplift. And these projected areas will enhance the capacity. This you can see in the book. Now, we will explain today the lateral load carrying capacity of piles. Why this is very much important? Because you can see whenever we are going to design a pile foundation, this is not only subjected to axial loads, but lateral load will come. The structures you have seen, transmission towers, high-rise buildings, and even sometimes small buildings also, say 3-4 story buildings also, sometimes lateral load creates a problem. And so as you have gone for compression as well as tension, but you have to know the lateral load carrying capacity of pile. Now for this one, you open IS 2911 IS 2911, all of you are having. You open IS 2911, Part 1, Section 2, Annex C. Two 2911, Part 1, Section 2. Can you see this? All of you can see.
Yes, sir.
Yes, sir.
This is, you can see, analysis of laterally loaded piles. Step-wise methodology is given here. How to get the lateral load carrying capacity of a pile. This is equally important as you have got for the vertical load, either compression or tension, but lateral load carrying capacity is also very much vital. Now in this case you can see that depending on the, if you look into the if you look into the mechanism, how the failure will take place, in case of lateral load, one pile is there and you are pile is there, then it is subjected to lateral load. So where from the resistance will come? In earlier case, when you have this one, you can see, you see. So in this pile, you are giving the vertical load, so the resistance is coming from the friction and point bearing. Am I correct? Now in case of lateral load, if this is subjected to say lateral load, then if you are applying say lateral load, then where from the resistance will come? Suppose in this case you have got load versus deformation curve. So this is a deformation and this is suppose load Q. You have applied say Q. So you have got this type of curve. Am I correct? Now similarly, if you apply horizontal load, then what will happen? Here the settlement is vertical. So in this case, the pile will deflect like this, isn't it? The pile. So in this case, you will get resistance from this side. You will get resistance from this side. Are you getting my point? If you applied horizontal load, then the pile will deflect and the soil will provide the resistance against the deformation. It will try to resist the deformation. So when this load is coming, this, if we take a small piece, the horizontal load, this will be your eta h into say delta. Okay, that means you are accustomed with the term. You are accustomed with the term say P equal to K delta. Can you remember? Have you gone through P equal to K delta? Force equal to stiffness into deflection or deformation. So here you know the subgrade reaction K, that is load per unit deformation. Now what is this now? This will be the horizontal subgrade reaction. Horizontal subgrade reaction. Now one important aspect you can see that whenever you are looking for this horizontal load, what was the purpose of putting pile foundation? To transmit the load to lower dependable soil profile. But unfortunately, you can see when you are dealing with horizontal load, you are getting the contribution of the top layer. Are you getting the point? Orphan Mandal is there. Orphan Mandal. Shall I put absent? Arpan? Kobita, can you listen me?
Yes, sir.
So now you see, whenever we have given pile, we are transferring the load to the dependable soil, but topsoil we know it will be weak. But when we are going for the contribution for the horizontal load, at that time we have to take the horizontal subgrade reaction of the soft soil. That's why I told you that this is very much vital regarding load carrying capacity. So what you have to know, the basic mechanism is coming the horizontal subgrade reaction. Horizontal subgrade reaction is vital. So if this is very low, then your within allowable limits, the load carrying capacity is very low. So basic mechanism is basically the passive resistance developed by the soil layer at the top to resist the deformation of the pile is contributing as lateral load. So this is all about the mechanism what we have initially we have explained regarding the uplift capacity as well as the compression. Now this is the mechanism for your horizontal load carrying capacity. Now this horizontal load carrying capacity, different method is there. Today we are going to explain the only the IS code method, but you go through the codes, there are different your methods are available that you can see. Now let us come back to the Annex C of IS 2911 part 1 section 2. Here you can see P by Y is equal to eta H Z. Eta H your modulus of subgrade reaction for which the recommended values are given, and P lateral load reaction per unit length of the pile at depth Z below the ground level. So this one basically some sort of modulus of subgrade reaction. Now this all of you are having the code. Can you see it?
Yes, sir.
Now there are two tables given. Table 3, you can see eta H is given into 10 to the power 3. You will remember the units very carefully because some empirical formula we are going to use. If you do not use the units properly, you will be very in a trouble. You will not be able to compute the correct value. Now this table 3 is for granular soil. You can see very loose sand, medium sand, dense sand, like that. And depending on N value, either in dry state or summer state, the values of eta H is given. This is one table. Then you come to next table. Table 4. This is given for cohesive soil. You can see here, it is based on unconfined compressive strength. Say for example, one soft clay is there. You are having cohesion, say example, say 25 kilopascal. So what is QU then? If C is 25, then what is QU? C is 25 kilopascal. Then what will be QU? QU equal to twice C, isn't it? So that part you have to take care. When the soil profile cohesion is given, you convert it to unconfined compressive strength and read the K1 value accordingly. And in between values, you interpolate. So suppose Q is 50, you will take K1 value as 9 into 10 to the power 3. Clear? Now you come back to this formula. Once K1 will be given, you can calculate capital K, and this K will be used in. Now you can see one stiffness factor you will calculate. For sand, you will be using this formula, T equal to 5th root of EI by eta H. Eta H already you have got from this table. Use proper unit. E is the, for that you have to know the grade of concrete that you are using in pile. I is the moment of inertia of the pile. So if you use a pile of diameter say 500, I will be pi into 500 to the power 4 by 64, and your E is 5000 into root over FCK. এখানে রেখে দাও, হলুদ যায় 5000 into root over FCK, E you will get. So you can calculate eta H, you can calculate T, and in case of granular soil, what you will do, you will calculate stiffness factor using this for cohesive soil. You will calculate this one, R equal to 4th root of EI by KV. K you have got from here, K1 by 1.5 into root 3 by B. B will be the width of the pile shaft or diameter. EI you know, so now you are position to calculate the R value and T value in case of sand you will use T, and instead of clay you go for R. Can you do it? So let us take one example, that will be better. You take one example. Say this pile having length say 20 meter, but it will not come in picture while calculation lateral load, and you take C equal to say 25 kilopascal. Now let us calculate the horizontal load carrying capacity of the pile. Pile diameter you take D equal to say 500 mm. Please write down this. So now for 25, C equal to 25, what will be the value of small k1? You see table 4. What will be the value of small k1? Anyone please?
9.
9.0, isn't it, into 10 to the power 3? But keep in mind the unit kilonewton per meter cube. Now you calculate the R value, that is stiffness factor. You take the stiffness factor now. R value you can calculate now. You take the grade of concrete M30. Grade of concrete you take M30. So now you calculate E, I, and then you calculate the R value. You calculate the R value. You calculate the R value. Okay. And put your R values in the chat box. I am recording it. Okay, so that it
Sir,
will be
what is the
recorded.
value of EI?
Length I have told 20 meter. You put it in the chat box, what R value you are getting roll number wise. Calculate the R value and give it in the chat box.
साहब कुछ में आना है, चैट बॉक्स में डालना है।
खिड़की कौन खोल लिया, कुछ भी होता है, शायद देखता है क्या क्या है।
Any doubt is there, you ask me.
Sir, what is the value of EI?
Value of
EI.
eh?
EI modulus, Young modulus of pile material and moment of inertia.
Diameter I have given 600 mm. Diameter is how much given?
500 mm, sir.
diameter is. So I you can calculate, and I have given grade of concrete. You can calculate E value. I have given the grade of concrete and diameter. So from here you will get I. E you will get from grade of concrete. 5,000 into root over FCK, isn't it?
Yes.
So everything is known. You calculate now. So small K1 you have got 9 into 10 to the power 3. Then E 5,000 into root over FCK. Then your I pi to the power 64. K1 you have got. So from there you can calculate capital K. Now you calculate R equal to 4th root of EI by KB. So how much time it takes? And use the proper units. E will be in meganewton per meter square, I will be in meter to the power 4, K will be meganewton per meter cube, P will be in meter, then R you will get in meter. You see the units properly in the code and use it. 3.73 meter. You have used the units properly. You are having grade of concrete 25, 30 na? 30 grade of concrete.
30.
So E value, how much you have got? This one you have got 27. Can you see my slide?
Yes, sir.
Don't copy. This will be 0.5. Have you got I this value in meter to the 4.003068? E value you have got this one.
Yes, sir. Yes, sir.
Yes, sir.
I value you have got. Then K1 will be 9. Then your R value will be 2.6. R value will be 2.6.
Sir, how K1 is 9?
9 because you see table 4. I have given cohesion 25 kilopascal. 25
Corresponding to
kilopascal
that,
means QU equal to 50. So corresponding to 50, the value is 9. You see in the
Okay.
table 4. Got the point?
yes, sir, got
Now
it.
you check what value I have told.
Sir, 2.6.
It is coming, na?
Yes, sir.
What's about others? Everybody is writing only 2.614 or doing the calculation correctly? Satya Pratap.
Yes, sir, done.
Okay. Please write it down in the chat box so that will be taken as attendance. Everybody has to do the calculation and take the. Mondal, have you checked again?
Get 100.
Penu Ramin, Penu is there.
Yes, sir. Yes, sir.
What value you have got? Any doubt is there? You tell me.
Okay, sir.
Okay, fine. So R value you can calculate. Now you look into the code. You see this chart, figure 4.
ये हम लोग रूम में
Figure
कहीं आ जा
4.
रहे हैं तो दे रहे देखने ये जो नाम ले लिए तो सबको भी दिखा दूंगा हासिल किया
You see,
फोटो भेज
when we
दीजिए
are considering a pile,
ओके देखो
when you are considering a pile, then the pile will deflect like this. So we will assume
नहीं है अभी
when the pile is deflecting like this, we assume that it is somewhere it is fixed. This is completely an assumption. Okay. So accordingly, we calculate the depth of fixity from ground level to the assumed depth of fixity. Okay. Okay. So this is, we are assuming the depth of fixity. Now, if we see that this part, this depth of fixity from here to here, we have to calculate. And if you look into a cantilever beam, somewhat like this, if it is fixed cantilever, if you put a load over here, then it will get deflected like this, and you will get a deflection here. Y is equal to P L cubed by 3I. Am I correct? Huh? Penu? For a cantilever beam, we know. So in case of pile, if this is the depth of fixity, if we can calculate, then we'll be able to see that how much deflection will take place here. And so on, we'll know the allowable deflection. We can see that how much lateral load will be taken care of. That means EI, 3EI into Y divided by L cube, if we make, we'll get the horizontal load. So this is the basic mechanism or mechanics behind this. So now you understand that we have to calculate the depth of fixity. Now let us go to the code again. If you go back to the code, you see here. Can you see the slide? This figure, can you see?
Yes.
Figure 4. We are now concentrating to calculate the depth of fixity part. And in the code, you can see, say, suppose one pile is here. So from, this is suppose a ground level. From here, LF is the depth of fixity, and L1 as if the eccentricity. L1 is the eccentricity and LF is the depth of fixity. In case the lateral load that you are considering the ground level and there is no eccentricity, then L1 will be 0, isn't it? So in this chart, you can see the condition given, LF by R or LF by T. You know, T was the stiffness part and R was for the clay soil, and this is for, so depending on that, either LF by T or LF by R you will. Then here you can see L1 by R or L1 by T. L1 means the eccentricity part. In case eccentricity is 0, then we will take reading only along y-axis. If you are any doubt, you can ask me. Now again, you can see here two conditions. One is pile in sand and normally constituted clay. These two chart, and for piles in preloaded clays, this is chart. Now again, in between two chart, one is dashed line, you can see fixed headed pile, another one is free headed pile. So depending on soil type and the fixity at the pile head, we will calculate the LF value from this chart. Any doubt is there, you tell me. So it is okay. Now when we will call our fixed headed pile and where we will free head pile? Anyone can say? We have explained in the first class, I think. When the number of piles in a pile group is more than 3, we will call it as fixed headed pile. You will be looking into 6.5.2.1 of the code IS 2911. 6.5.2.1, there the condition is given. If the number of piles in a pile cap group is more than 3 and more than 3, 3 or more than 3, it will be fixed head. Otherwise, it will be free head. Again, if the pile is restrained in both the direction with tie beams, then also we can consider it as a fixed head pile. So 6.5.3.1, you go through, you will get the definition of 6.5.2.1. You will get the definition for fixed and free head condition. So now let us assume your case, say fixed head case. So which curve will read here? Suppose eccentricity is 0. So we will take L1 corresponding to L1 by R equal to 0. So if we take it as fixed headed pile, so we will get the dash line. So what is the value for us now? This LF by R, in our case R we have calculated. So LF by R for fixed head pile, for without eccentricity, that is L1 equal to 0. What is the value? Anyone can tell? What is the value of LF by R here? If we take this clay group and if we take this fixed pile, what is the value here? Can you see the graph?
2.0.
2.0, correct. So now you can see very easy. You have got LF by R equal to 2.0 and you got the R value. So can you calculate the LF value? So 2
Yes,
into
sir.
2.6 something, 2 into 2.614 something 612 you have got. So you multiply it. So you will be getting it 5.2 or 3, isn't it?
Yes, sir.
So depth of fixity you are getting 5.2 or 5.3, whatever it is. So very easy to get the depth of fixity. Why we are calculating the depth of fixity? As I have shown you above that, as if it will be considered as a beam and subjected to flexural moment. Now we have to calculate the moment. If it would have been a cantilever beam, what is the moment? Load multiplied by the depth of fixity here, isn't it?
Yes,
312.
sir.
So L is known, the fixity depth, but in reality it is not the case. So that's why you go to C 4.2. Here the formula is there. Y equal to, you can see the same formula, PL cubed by 3EI. Y will be in millimeter, that's why it has been multiplied by 10 to the power 3. H is the horizontal load, E is the eccentricity, ZF is the depth of fixity, and 3EI has come. That means PL cubed by 3EI for fixed head pile. It is clear? So in your case, you will put E equal to 0, ZF equal to, you have got 5.3, and Y code has recommended that this will be 5 millimeter. I am coming to that point. Now, so this is for free head pile, and for fixed head pile, it is PL cubed by 12 VI, because in case of fixed head pile, it will take more load. So in fixed head pile, you will be using this formula, and free head pile, you will be using this formula. So now can you, if Y is given, can you calculate now H for free head and fixed head condition? Other parameters are known to you. You have calculated already ZF, but that will be for fixed head pile, and free head pile will be different value. This is we have got for fixed head pile, and for free head this is less, 1.62 or something like that. So you will be using the corresponding formula, and then you can calculate. So now can you calculate the H value from this formula for fixed head condition and free head condition using Y equal to 5 millimeter? It is easy. Now let me tell you one point. In IS 2911, they have recommended y equal to 5 millimeter, this value. But this is not a correct picture, because if you look into the pile, you can see if you take a 500 mm pile, also 5 millimeter. If you take 1.5 millimeter pile, also 5 millimeter. If you take 3 meter dia pile, also 5 millimeter. Is it a correct specification? You see, without deformation, how the resistance will develop? So you have to allow more deformation for larger diameter piles. Then only you will get the load, isn't it? So for that IRC 78, please write down IRC 78 for beach coats. IRC 78 has recommended that this will be 1% of the pile diameter. This is good. 1% of the pile diameter. So if it is 600 mm, 6 millimeter, 1 meter dia, 10 millimeter, 1.5 millimeter, 15 millimeter. So now you can see that in the formula, this y value as per IRC will be different, but as per 2911 it is different. So you can now calculate the h value, and you can calculate the fixed end moment also like this, mf equal to h into that L. And for fixed headed pile, fixed end moment is for free head, and for fixed end, you know, the moment will be less, carryover will take place. So this by 2. In addition to this, there is some reduction factor, because this is not the reality, the way we are considering cantilever beam and calculating the deformation, pile deformation. So there is some reduction factor also there. So now you are in a position that for a given soil profile, you can calculate the horizontal load as per IS 2911, and also you can calculate the moment. Yes or no?
Yes, sir.
So for a given soil profile, as you know, the top layer is coming in the picture, and you have got the depth of fixity, so that is contributing the alternator load. So you calculate take the proper parameters, either eta h or k1, table 3 or table 4. Then you calculate either T or R. Then you get the value of L1 by R, LF by R, or LF by T from the figure 4. Then you calculate the from given Y value, either 5 millimeter or as per IRC you can take. So you will get the H value. Fixed head condition and free head condition will be different. So after calculating that, you are in a position to get the moment also due to the lateral load. So now if we see, you are in a position to design the pile. You have calculated geotechnical capacity, vertical load, lateral load, uplift, and moment. So now you can design the pile structurally. Have you done column design with biaxial uniaxial moment? Have you done column design? RCC column?
Yes, sir. Yes, sir.
Yes, sir.
So accordingly, you can calculate PU by FCK BD and MU by FCK BD square, and you will get the reinforcement P by FCK. But in pile, minimum reinforcement is 0.4%. In case of column, you have got minimum reinforcement is 0.8%. Am I correct? But in pile, it is 0.4%. Now, in case the moment is high, then up to depth of fixity, you will be providing more reinforcement. Then you give your development length, and below that you can give also less more reinforcement. But in tension pile, you give throughout the reinforcement. Don't curtail it. In case of tension pile, as you know, if you design a concrete member under tension, the reinforcement only will take the tension, and concrete takes very less, that we neglect in pile. So you can design the structural part also. Now link, you keep it in writing, don't forget it. Again, in 3D of the pile, will provide more link, and later part you can give minimum, because in case of earthquake there is possibility of hinge formation in the pile and pile cap. So this thing we can discuss even in next semester. Okay, so load carrying capacity of pile, you are now confident? Yes or no? Vertical, uplift, lateral, everything you can do. Now let us go to so single pile. Till now we have explained single pile. Now we'll go for pile group. Till now for the single pile, everything we have explained, load carrying capacity. If you have any doubt, you can tell me. Do you have any doubt?
Sir,
Anand Kumar, how?
sir, how the deflection will
Yes, sir.
increase by diameter of pile. If increase the diameter, then how will the deflection increase? It should be inverse.
Okay. Pile diameter.
Yes, sir.
Pile diameter, you see, depending on the soil profile, you will calculate the from the superstructure, they will tell the load will coming. So when in a column load is there, that will also explain in next semester. When the column load is given, moment is given, then you have to assume a pile group. In the pile group, then you have to calculate the load. That will explain in the extreme pile how much load is coming. Once the load is coming, then as per your soil profile, you can change the diameter and get the pile diameter to take the allowable load that is required from the structural loading point of view. Accordingly, the diameter will be fixed up. Okay. So you will do the calculation 500, 600 or 700. Then you see that which diameter is comfortable to take your load or easy allowable, that diameter will fix. Length also same thing. Length always you will try to raise the pile in a stiffer layer, and depending on the length also you will calculate the capacity. If you increase the length, capacity will increase. Sometimes this is not true. Suppose a pile is you are resting on sand and immediately below it is going to clay. If you put it in clay, you may even this is the thing, even increasing the length you may get less capacity. This is the engineering judgment basically you have to do. Where the pile should rest, what should be the length, that you have to do. Okay. Any other question? Do you have any other question? This practical aspect again I will discuss in the next semester in the advanced foundation design. Okay. So আমি ক্লাস নিচ্ছি ঘরে, তুমি কি এসছো? So can we move to next slide? Now let us go for the pile group. Okay. So as you see that in most of the cases, and from fixity point of view, we need minimum 3 piles in a group. Hello, আমি ক্লাসে আছি এখন। হ্যাঁ, so after now how we will decide the spacing part, how the spacing we can decide. You see this slide. So you have to fix up the spacing how the failure will take place, mechanism, group efficiency and settlement. These are the points we are going to discuss. First of all, which is not here, let me tell you. Suppose you got a column. Yes, any doubt is there? So whenever you are putting a load here, from the column it is coming. So you have to decide that what will be the number of piles. So now whenever you have decided the number of piles, then what is the spacing? I will decide the spacing. Then we'll go for the mechanism part. Then what is the group efficiency and how to calculate the settlement. So if we decide the number of pile, say for example from load carrying point of view, I require suppose say 2 by 2 pile. If it is 2 by 2, say 4 piles are sufficient to take the load, then what will be the spacing between the piles? Now the spacing will be decided based on the failure criteria. Now you can see whenever one pile is giving the load, these are the pressure valve. Can you understand? For a single pile, this type of pressure valve will form. Whenever you are going to a group, you can see there will be overlap. There will be overlap. Now if you increase the spacing again, there will be no overlap. So now you can see the spacing is more, then the probability of interference of the pressure valve is less. But can we make the spacing very high? So the factors that will be considering overlapping of the pressure valve of adjacent piles, cost of foundation and efficiency of pile group. Now you can see if you go for increasing the pile cap or spacing, then there will be no interference, but the cost of the pile cap will increase. Not only that, even in a project, you may not be able to accommodate them. There will be overlap. Suppose this is a area where you are going to have. So suppose this is one column, this is one column, this is one column, this is one column. So there is restriction of the size of the pile cap also. You for a single column, if you take the whole area, then what will do for the remaining 3 columns? For that also you have to provide the pile. So you cannot go on increasing the size to avoid the interference. That is not possible. So again, the interference should be less so that you will get the proper capacity, and your cost of foundation also should be less. So keeping all these things in mind, overlapping, cost of foundation and efficiency of pile group, there are some guidelines are given. These are like this: friction piles, minimum pile spacing is 3D, end bearing passing through compressible soil layers. That means in this case you will get the contribution from the bottom layer mostly. So here the spacing can be given taken to 2.5D. Then end bearing passing through compressible layer resting on steep clay, in that case 3.5D, and for compression pile this is 2.5D. So you can see that in most of the cases your spacing will vary from 2.5D to 3D. So this is the idea how we fix up the spacing of piles in a pile group. If any doubt is there, you tell me.
Maximum
Do
spacing.
you have any doubt? Huh?
Maximum spacing.
Spacing is the center to center of a pile, two piles.
Sir, you
I
have
have
told
shown on
about the minimum. So what will be the maximum? What will be the maximum?
No. If you make maximum, then the cost of the foundation will increase. So you have to optimize. And another one point I have told you, if you go on increasing, then you may not be able to in a position to accommodate all the piles for other columns. What the point?
Yes, sir.
So that will guide you that how you can go. So you have to look into the load transfer mechanism as well as the cost of the part and also accommodating the piles for all the columns. That's why there are some problems. Sometimes we cannot afford for even 3D, that we need to compromise again. Any doubt is there regarding spacing? You tell me.
Sir, what if the diameter of the piles are different?
The different pile diameter, that will be decided earlier already. That has been decided already from capacity point of view. First you get the soil report, then you loading from the column, then you decide what will be the diameter. After that you go for the spacing. This is the step. Okay. Diameter you have decided already. Now Pandey has told that Pandey has told for 30 minutes break and then they will come back. So what is your idea? Do you want to go for lunch then come back? Will it be available right now? Lunch is available.
Yes, sir.
Then you go for lunch, but don't take 30 minutes. You take 20 minutes and come back. Huh? So we can start the class at 1:10 or so.
Yes, sir.
Okay,
sir.
Okay, please. Till now, up to whatever doubt is there, you tell me. If any doubt is there, it's okay. If doubt is not there, then also it's okay. After coming back, so you can ask me. But please come join the class at 1:10. We'll start. Okay. I am not leaving the class actually. You just join. Okay. 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 You come at 1:10.
कोई लीव क्यों नहीं कर रहा है?